static routing, dynamic routing with IPv6 RIP, IPv6 EIGRP, and single area IPv6 OSPF. We're going to touch on IPv6 access control lists, although honestly they're not a whole lot different from what you have with IPv4. And then we'll go into some IPv6 security considerations. As you can see, we've got a pretty aggressive agenda to cover in a fairly short period of time. So we're not going to go really deep, but I think that by the end of the webinar, you should have a pretty good sense of how to implement IPv6 on a Cisco router. It's not terribly difficult. And we've also got some resources for you, some online resources to help you in the process down the road. Let's talk about types of IPv6 addresses. So there's really three types. There's unicast, multicast, and anycast. Broadcast messages are not used in IPv6. And anybody who's been involved in data networks for any length of time knows what vain broadcast messages can be to network traffic and to bandwidth. So that's good news. A unicast is where the packet is delivered to a single interface. A multicast is the same as in IPv4, where a packet is delivered to multiple interfaces. But now we have an anycast address, and that's where a packet is delivered to the nearest of multiple interfaces, typically on multiple nodes. And Tom and I were talking about this while we were working on the book, and he commented that a great use of this is with DNS. So you can find your closest DNS server by sending an anycast packet out, and it then is based on routing information. It determines where the closest DNS server would be. So that's an example of an anycast address. Now, we have several IPv6 scopes. I'm not going to go over all of them, but I do want to touch on some of them. A linked local scope is the local, that's the nodes on the same subnet. Then you have a unique local, where the scope is the entire organization, and then we have global, which would be the IPv6 internet addresses. Now, here are some types of IPv6 addresses. The unicast global addresses are similar to IPv4 public addresses. Anytime you see the word global, that kind of indicates that we're talking about things out of the public internet. They're globally routable on the public internet, and they have a prefix of 2000:/3. Now, if you're not familiar with IPv6 addresses, I'm not going to go into a lot of detail on them. You'll see several examples as we go through the webinar, but it's a 128-bit address, and just the same as insider notation with IPv4 addresses, that slash value at the end indicates the total number of bits in the network portion of the address. So in the case of a unicast global address, the first 3 bits are the network portion of the address. You can obviously extend that through subnetting processes, but by default, in the case of the unicast global, the first 3 bits are the network addresses. Then we have unique local addresses. These are similar to IPv4 private addresses. You may think of them as the RFC 1918 addresses. Well, when we get into IPv6, this is RFC 4193. And let me just mention that the RFCs are really, just as always, a tremendous source of information on how to configure IPv6. And that is generally not just limited to Cisco. So when you want to know about IPv6, take a look at the RFCs, and we'll give you some RFC recommendations toward the end of the webinar, and also set up a web page to support that as well. Unique local addresses use the address block of FC00::/7. Now, one comment, again, for those of you who are brand new to IPv6, that : is a way of replacing a string of zeros. So if it comes at the end of the address like it does here, then that simply represents a lengthy string of zeros. It's shorthand.